Trigonometry, Chapter 1, Trigonometric Functions, Section 4, Using Definitions of Trig Functions, Video 5, Domain and Range of Sine and Cosine. This series is based on content from Pearson's 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous videos, we discussed the signs of trig functions based on the quadrant containing the angle's terminal side, assuming the angle was in standard position. In this video, we discuss the domains and ranges of two of the six trig functions, sine and cosine. Recall that for an angle theta, with the point xy not equal to the origin on the terminal side, we have sine of theta equals y over r and cosine of theta equals x over r, where r equals the square root of x squared plus y squared. Because xy is not the origin, we know that r is not equal to 0. Remember that r measures the distance from the origin to the point xy. Since r is never equal to 0, we know that sine and cosine are always defined for any value of theta. In other words, this fraction can never have 0 in the denominator. This simply means that the domain of both sine and cosine is all real numbers, or in interval notation, negative infinity to infinity. But what about the range? In other words, the outputs for sine and cosine. In order to determine that, we need to establish some inequalities. We know that r is equal to the square root of x squared plus y squared, so we have that r squared is equal to x squared plus y squared by squaring both sides of that equation. Now, we also know that 0 is less than or equal to y squared, because y squared is positive or non-negative. And because of that, we can deduce that x squared is less than x squared plus y squared, because we're adding a non-negative quantity to x squared, but x squared plus y squared is equal to r squared. So essentially, if you add x squared to both sides of this inequality, you get this one, and x squared plus y squared is equal to r squared. Now, since r squared is non-negative, and more specifically positive, we can divide both sides of x squared is less than or equal to r squared, so the extremities of this inequality. We can divide both sides of that by r squared without reversing the inequality. So if we divide both sides of x squared is less than or equal to r squared by r squared, we get x squared over r squared is less than or equal to 1. But wait a second. X over r is equal to cosine of theta. So the inequality x squared over r squared is less than or equal to 1 becomes cosine squared theta is less than or equal to 1. And just a comment, when you square a trig function, it's standard to write the exponent directly on the function. So cosine squared theta means the square of cosine theta. But the only way cosine squared theta can be less than or equal to 1, the only way that can happen is if cosine is between -1 and 1, inclusive. Think about it. Pick a negative number to the left of -1 and square it. It will come out positive and bigger than 1, which would violate this inequality. But if you pick a number greater than 1 and square it, then its square is greater than 1, which would also violate this inequality. So again, the only way cosine squared is less than or equal to 1 can happen is if cosine is between -1 and 1 inclusive. This means the range of cosine theta is the interval from -1 to 1, with brackets to include both endpoints. Now, you can do a similar argument to show that the range of sine of theta is also -1 to 1. I'm not going to walk it all out, but I'll show you briefly where the change would be. You would go back to here, and instead of saying 0 is less than or equal to y squared, you would say 0 is less than or equal to x squared. Then you would add y squared to both sides and essentially put y squared here, and then you would follow suit similarly. There are also geometric arguments explaining the domain and range of sine and cosine. I invite you to sketch an angle in standard position, complete with a circle through the point on the terminal side to see if you can derive these domains and ranges. Here's a summary of the domains and ranges of sine and cosine. In the videos that follow, we will determine the domains and ranges of the other 4 trig functions and add them to this table. Both domains are all real numbers, and both ranges are -1 to 1 inclusive. Now you try. Pause the video and try the following. Number 1, which of the following values are in the domain of sine? Number 2, which of the following are in the range of cosine? All right, here's your fair warning. If you haven't paused the video yet, solutions in 3, 2, 1.